3D bioprinting, also known as bioprinting, is an advanced manufacturing technology that combines three-dimensional (3D) printing techniques with biological materials to create living tissues and organ-like structures. This technology has the potential to revolutionize fields such as regenerative medicine, tissue engineering, and drug testing by allowing the precise construction of complex biological structures. Key aspects of 3D bioprinting include 1. Bioink. The primary material used in 3D bioprinting is a specialized, bioink. Bioink typically contains living cells, often stem cells, suspended in a hydrogel or other biocompatible matrix that provides the necessary structural support. 2. Layer-by-layer printing. Similar to traditional 3D printing, 3D bioprinting involves building objects layer by layer. However, instead of using plastics or metals, it uses bioink that contains living cells. This layering process is crucial for creating complex and precise biological structures. 3. Applications. 3D bioprinting has a wide range of potential applications, including tissue engineering, where it can be used to create replacement organs or tissues for transplantation, drug testing, disease modeling, and personalized medicine. It has the potential to address the shortage of donor organs and reduce the need for immunosuppressive drugs. 4. Regenerative medicine. In regenerative medicine, 3D bioprinting allows for the creation of patient-specific tissues and organs. This can help repair damaged or degenerated body parts, such as skin, cartilage, bone, and even more complex structures like heart valves. 5. Pharmaceutical testing. 3D bioprinted tissues can be used in drug testing and development. They provide more accurate models of human tissue for studying drug interactions, toxicity, and efficacy, reducing the need for animal testing. 6. Disease modeling. Bioprinted tissues can be used to create disease models, offering insights into disease progression, testing potential treatments, and personalizing medical approaches. 7. Challenges. While 3D bioprinting holds immense promise, it also faces challenges, including the need to ensure cell viability during and after the printing process, controlling tissue organization and vascularization, the development of blood vessels within the tissue, and scaling up to create complex organs like the heart or liver. 3D bioprinting is a rapidly evolving field, and research continues to advance its capabilities. As technology improves and our understanding of tissue biology deepens, 3D bioprinting is likely to play an increasingly important role in the fields of medicine, research, and healthcare. Subscribe for more videos. Thanks for watching.